our topic is permutations. Some letters are never together. In how many different ways can the letters of the word digest be arranged so that the vowels are never together? As we have seen in the earlier video, we have done the cases wherein the vowels are together, right? In this case, the vowels are never together. This would take 3 steps to solve. Let's see. First, step 1. Step 1 is we need to find in total how many words can be formed using the letters of the word. So, step 1 is total number of words that can be formed. Now, the step 2. What is the step 2? We need to find the number of words in which the vowels are always together. Okay? So, the second step will be vowels are always together. So, step 3. Step 3 is we need to subtract the words in which vowels are together from the total number. Then we get the vowels which are not together. Step 3 will be step 1 minus step 2. This is a 3-step procedure to solve such type of questions. Now, you may find it complicated right now, but once you practice it, it is very easy actually. Right? Our first word here is digest. First, step 1. What is our step 1? We need to find the total number of words that can be formed using these letters. How many letters are there? 1, 2, 3, 4, 5, 6. As the letters are not repeated, we take it as 6 factorial, which is equal to 720. Next, our step 2. Step 2 is the case in which the vowels are always together. As we have seen in the earlier video, whenever we need to take all the vowels together, we take a bracket. We keep the vowels inside the bracket. Here the vowels are I and E. The remaining letters are D, G, S, T. Now, this set of vowels should always be together. They can take the places here, 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 here or here. So, how many places? 1, 2, 3, 4, 5. In any of the 5 places, this set can come. That can be done in 5 factorial ways. Now, these two can be arranged within themselves in 2 factorial ways, which will be 5 factorial is 120, 2 factorial is 2, which is 240. Now, the most important step here, step 3. Step 3 is total 720 minus the case in which the vowels are together, that is 240. 720 minus 200 is 520 minus 40 is 480. So, there are 480 words in which the vowels are never together. So, it is basically very easy. First is to find the total number of cases. Step 2 is to find the words in which the vowels are always together. Step 3 is on subtraction this from this, we get the words in which the vowels are never together. Let's see the next question. In how many different ways can the letters of the word extra be arranged so that the vowels are never together? The keywords here are vowels are never together. 3-step process, right? What is the step 1? Total number of cases. Here our word is extra. It is a 5-letter word and no letter is repeated. So 1, 2, 3, 4, 5 factorial. These are the total number of words that can be formed. Step 2. Step 2 is the words in which the vowels are always together. Always together. Open the bracket, put the vowels inside the bracket, E and A. Write down the remaining letters here. Right. Now this set of EA can come here, 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 here. Any of the 4 places. That can be done in 4 factorial ways. These two can be arranged within themselves in 2 factorial ways. 4 factorial is 24 and 2 factorial is 2, which is 48. This step 3. Step 3 is subtracting this from this, right? So 120 minus 48. 120 minus 50 is 70 plus 2, 72. So 72 words can be formed in which the vowels are never together. Let's go to the next question. In how many different ways can the letters of the word honest be arranged so that the vowels are never together? Our keywords, vowels are never together. Step 1. Total number of words that can be formed using the letters of the word honest. How many letters are there? 1, 2, 3, 4, 5, 6. 6 factorial, which is 720. Next, step 2. The number of words in which the vowels are together. Open the bracket, put the vowels inside the bracket. We are left with the consonants H, N, S and T. Now this set of OE can come here, 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 here. Any of the 5 places, right? So in 5 factorial ways. And OE can be arranged within themselves in 2 factorial ways. 5 factorial is 120, 2 factorial is 2, which will be 240. Now, step 3, the last step, 720 minus 240. 720 minus 200 is 520 minus 40 is 480. So 480 words can be formed in which the vowels are never together. Our next question, in how many different ways can the letters of the word be arranged so that the vowels are never together? Here are keywords, vowels are never together. And our word is arrange. If we can see here, few letters are repeated. What are those? A is repeated twice and R is repeated twice. Whenever letters are repeated, we go for the denominator, right? So step 1. What is step 1? Total number of words that can be formed using the letters of the word arrange. So total how many letters? 1, 2, 3, 4, 5, 6, 7. We have 7 letters. So it is 7 factorial divided by A is repeated twice, so 2 factorial. R is repeated 2 times, so 2 factorial. This will be 5040 divided by 2 factorial is 2, 2 2s are 4. This comes to be 1260. Next, step 2. Step 2 is total number of words that can be formed in which the vowels are together. First, let's place the vowels in the bracket. What are the vowels here? A, E. The remaining letters are R, N and G. This set of E can come here, 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 here. How many places? 1, 2, 3, 4, 5. In any of the 5 places, this set can be placed in 5 factorial ways divided by, here R is repeated 2 times, right? So I am taking 2 factorial into, now this set of E can be arranged themselves in 3 factorial divided by 2 factorial ways. This will be 5 factorial is 120, 2 factorial is 2, 3 factorial is 6, 2 factorial is 2. Right? 2 2s are 4. 4 into 30. 36 are 180. Now, our step 3. Subtract step 2 from step 1. So, that will be 1260 minus 180. 1260 minus 200 is 1060 plus 20, 1080. So 1080 words can be formed in which the vowels are never together. Just be careful here because the letters are repeated. We get the denominator. Step 3 is step 1 minus step 2. The next question, in how many different ways can the letters of the word replace be arranged so that the vowels are never together? Our word is replace. Here the letter E is repeated 2 times. The step 1. Total number of words that can be formed using the letters of the word replace. 1, 2, 3, 4, 5, 6, 7. We have 7 letters. So it will be 7 factorial divided by E is repeated 2 times. So we get 2 factorial, which is 5040 divided by 2. This 2520. Next, step 2. The number of words in which the vowels are always together. Keep the vowels in the bracket. What are the vowels here? E, A, E. What are the remaining letters? R, P, L, C. Now this set can come here, 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 here. 1, 2, 3, 4, 5. Any of the 5 places, right? So 5 factorial. Here no letter is repeated. R, P, L, C. No letter is repeated. Multiplied by. Now this set of E, A, E can be arranged themselves in 3 factorial ways divided by E is repeated twice. So 2 factorial, which will be 5 factorial is 120, 3 factorial is 6 divided by 2. 2 ones are 2 3s are gets cancelled. 3 into 120 is 360. Now step 3. Step 3 is step 1 minus step 2. So 2520 minus 400 will be 2120. 2120 plus 40, 2160. So the answer is 2160. The next question. In how many different ways can the letters of the word producer be arranged so that the vowels are never together? Our word is producer. Which letters are repeated here? R. R is repeated twice. There are no other repeated letters, right? No. Step 1. Step 1 is total number of words that can be formed using the letters of the word producer. 1, 2, 3, 4, 5, 6, 7, 8. It is a 8-letter word. So we have 8 factorial divided by R is repeated twice. So 2 factorial. 8 factorial is 40320 divided by 2. 20160. Now step 2. The number of words in which the vowels are together. Place the vowels in the bracket. O, U, E. What are the remaining letters? P, R, D, C, R. So how many blanks can be there? 1, 2, 3, 4, 5, 6. So this set of OUE can come here, 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 here. Any of the 6 places, right? So that can be done in 6 factorial ways divided by, here we have R repeated twice. So 2 factorial into OUE can be arranged themselves in 3 factorial ways. 6 factorial is 720 divided by 2 into 6. 2 ones are 2 3s are. 720 into 3 is 2160. Now our last step. Step 1. 20160 minus 2160, which will be 20 minus 2 is 18. So 18,000 words can be formed in which the vowels are never together. Our next question on the screen. In how many different ways can the letters of the word outline be arranged so that the consonants are never together? Here consonants are never together. First of all, what is our word? Outline. Are there any letters repeated? No. How many letters are there? 1, 2, 3, 4, 5, 6, 7. It is a 7-letter word. First, step 1. Total how many number of words can be formed? using 7 letters, 7 factorial, which will be 5040. Step 2. The number of words in which the consonants are together. Put the consonants within the bracket. That will be T, L, N. The remaining letters should be written outside. O, U, I, E. This set of consonant can be placed before O, or in between O and U, or in between U and I, or in between I and E, or after E. In any of these 5 places, this set can be placed. That can be done in 5 factorial ways, because we have 5 places, right? So 5 factorial ways. Into these 3 letters can be arranged themselves in 3 factorial ways. 5 factorial is 120, 3 factorial is 6. Now 120 into 6 is 720. What is our step 3? Step 2 subtracted from step 1. 5040 minus 720, which will be 250 minus 7 is 43. 4320. So 4320 words can be formed in which the consonants are never together. Whenever we have consonants are never together, we need to take the consonants as a separate unit and solve the problem. The next question, in how many different ways can the letters of the word shape be arranged so that the consonants are never together? Our word here is shape. This is a 5-letter word and consonants are never together, right? So step 1, total number of words that can be formed using these 5 letters will be 5 factorial, which is 120. Step 2. The number of letters in which the consonants are together. Open the bracket, put the consonants inside the brackets, place the remaining letters outside, right? Now this set of AE can come here, here, here or here in 4 factorial ways. In any of the 4 places, this set can be placed in 4 factorial ways. And these 2 can be arranged themselves in 2 factorial ways. 4 factorial is 24 and 2 factorial is 2, which will be 48. Now, step 3. Step 3 is 120 minus 48. 120 minus 50 is 70 plus 2 is 72. So 72 words can be formed in which consonants are never together. Next question, in how many different ways can the letters of the word routine be arranged so that the consonants are never together? Our word is routine. Are there any letters repeated? No, nothing. So how many letters word? 1, 2, 3, 4, 5, 6, 7. It is a 7-letter word. Step 1. Number of words that can be formed using these 7 letters. 7 factorial, which will be 5040. Now, step 2. Number of words that can be formed in which the consonants are together. Put the consonants within the brackets. R, T, N. What are the remaining letters? O, U, I, E. Now this set of R, T, N can come here or here, here, here or here. In any of the 5 places. That can be done in 5 factorial ways. And these 3 letters can be arranged themselves in 3 factorial ways. 5 factorial is 120, 3 factorial is 6, which is 720. Step 3 is subtracting step 2 from step 1. 5040 minus 720. This will be 4320. So 4320 words can be formed in which the consonants are never together. The next one. In how many different ways can the letters of the word comment be arranged so that the consonants are never together? Our word is comment. if we can see here, few letters are repeated, right? So M is repeated 2 times. Okay, remaining are all non-repeated letters. So step 1. Total number of words that can be formed using these letters. 1, 2, 3, 4, 5, 6, 7. 7 factorial divided by 2 factorial, as M is repeated twice. 7 factorial is 5040 divided by 2, which will be 2520. Now step 2. The number of words in which the consonants are together. Put the consonants within the brackets. What are the consonants here? C, M, N and T. What are the remaining letters? O, E. Now this set of consonants can come here between O and E or after E, right? In 3 places. In any of the 3 places, this set of C, M, N, T can come. So 3 factorial ways into, now 1, 2, 3, 4, 5. 5 letters can be arranged themselves in 5 factorial ways divided by 2 factorial, because M is repeated twice. Now 3 factorial is 6, 5 factorial is 120, this is 2. 2 cancels 120 in 60 times, 60 into 6 is 360. What is our step 3? 2520, that is step 1 minus step 2, 360. 2520 minus 400 is 2120. 2120 plus 40 is 2160. So 2160 words can be formed in which the consonants are never together. Our next question, in how many different ways can the letters of the word bullet be arranged so that the consonants are never together? Consonants never together. What is our word? Bullet. Bullet. L is repeated 2 times. How many letters word? 1, 2, 3, 4, 5, 6. It is a 6-letter word. Step 1. Total number of words that can be formed using these 6 letters is 6 factorial divided by 2 factorial. 6 factorial is 720. 2 factorial is 2, which will be 360. Step 2. The words in which the consonants are together. Place the consonants in the brackets B, L, L, T. What are the remaining letters? U and E. This set of B, L, L, T can come before U or in between U and E or after E. In any of the 3 places, this set can come. That can be done in 3 factorial ways. Now, B, L, L, T, these 4 letters can be arranged themselves in 4 factorial divided by 2 factorial ways. This will be 6 into 4 factorial is 24 divided by 2. 2 ones are 2 12s are 6 12s are 72. Step 3. Step 3 is 360 minus 72. 360 minus 60 is 300, minus 12 is 288. So 288 words can be formed in which the consonants are never together. The next question, in how many different ways can the letters of the word transition be arranged so that the consonants are never together? Our transition. We have few letters repeated here. What are they? T. Letter T is repeated 2 times. R, A, N. N is repeated 2 times. S, I. I is repeated 2 times. Now, step 1. How many letter word is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 letter word. Don't get scared. Same procedures. 3 steps procedure. The first step, total number of words that can be formed using these 10 letters. That will be 10 factorial divided by T is repeated twice 2 times. I is repeated twice 2 times. N is repeated twice 2 times. 10 factorial is I have told you to remember these 0 to 10 factorial is very important. 3, 6, 2, 8, 8, 0, 0, 2 to the 4, 4 to the 8. Step 2. Step 2 is total number of words in which the consonants are together. Place the consonants within the brackets. T, R, N, S, T, N. What are the remaining letters? A, I, O. Now this set of consonants can come here or here or here or here or here. How many places? 1, 2, 3, 4, 5. In any of the 5 places, this set can be placed in 5 factorial ways divided by, here I is repeated twice. So 2 factorial into these 6 letters can be arranged themselves in 6 factorial divided by T is repeated twice 2 times, N is repeated 2 times. So 2 factorial, which will be 5 factorial is 120 divided by 2 into 720 divided by 4. 2 4s are 8. 720 goes in 8 table for 90 times. So 120 into 90, it is 10800. Step 3 is subtract step 2 from step 1. That is 453600 minus 10800, which will be 442800. These many words can be formed in which the consonants are never together. Don't get scared if you get a 10-letter word or 12-letter word. The procedure is the same. Just be careful with the calculation part. Now it's good to remember from 0 factorial to 10 factorial. That is the reason I was able to write this value easily. Some letters are never together case. The next question, in how many different ways can the letters of the word quickly be arranged so that the letters C and K are never together? Here the specific letters are there. First of all, let us note down our word quickly. How many letters do we have in this word? 1, 2, 3, 4, 5, 6, 7. 7 letters. Step 1 will be total number of words that can be formed using these 7 letters. That is 7 factorial, which will be 5040. Next step. Step 2. Step 2 is total number of words in which the letters C and K are together. So place the letters C and K inside the bracket. What are the remaining letters? Q, U, I, L, Y. This set of CK can come here or in between Q and U, or here or here, here or here. So how many cases? 1, 2, 3, 4, 5, 6. In 6 places I can place this set in 6 factorial ways. As we can see, no letter is repeated. So 6 factorial ways, and CK, KC. We have 2 cases here, right? So 2 factorial. 6 factorial is 720. 2 factorial is 2, which will be 1440. Step 3. Step 3 is subtracting 1440 from 5040. 5040 minus 1440. Which will be 50 minus 10 is 40 minus 4 is 36. 3600 words can be formed in which C and K are never together. In the earlier problems, we have seen vowels are never together, consonants are never together. But here they specified that the letters C and K should never be together. Our last question, in how many different ways can the letters of the word corporation be arranged so that the letters R, P and N are never together? What is our word? Corporation. Here the letter R. R is repeated 2 times. And the letter O is repeated 3 times. Right? Only these 2 letters are repeated here. Now, how many letter word is it? 3, 6, 9, 11. It is a 11 letter word. The step 1. Don't get scared seeing 11-letter word, okay? The same 3-step procedure has to be followed. Step 1 is total number of words that can be formed using the 11 letters. That will be 11 factorial divided by R is repeated 2 times. So 2 factorial, O is repeated 3 times, 3 factorial. I'm not going to simplify this, let it be this way. Now step 2. Step 2 is the words in which R, P, N are always together. So first let's place the letters R, P, N together. We have 2 R's here. Okay, done. Now what are the remaining letters? C, O, O, A, T, I, O. Right, now this set of R, P, R, N can be placed before C or here, 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 here. Any of these places. 1, 2, 3, 4, 5, 6, 7, 8. In any of the 8 places, I can place this set in 8 factorial ways. Divided by 1, 2, 3. O is repeated thrice. So 3 factorial into. So R, P, R, N. These 4 letters can be arranged themselves in 4 factorial divided by 2 factorial ways. So this will be 2 into 8 factorial. Now next step 3. Step 3 is we need to subtract the step 2 value from step 1. So 11 factorial divided by 2 factorial into 3 factorial minus 2 into 8 factorial. This is going to be your answer. This is a 11-letter word, but the steps we are following are the same. Such big numbers are usually not asked in the exam, but still we should follow the same process. I just wanted to tell you that even if it is a big word or a small word, the same 3 steps are to be followed. Thank you.